Here's the mechanical overview of my cat-in-a-box personal project. We have here a system of gears. I modeled these in SolidWorks, which is a CAD modeling, which is more precise. It's used for mechanical parts like this. We have a servo, which when it gets a signal will run these two gears. This is a 2-to-1 gear ratio to increase the mechanical advantage because this servo is extremely weak. And what this will do when it receives the input is it will raise these cams on the back right here. There are 3 cams, 1, 2, 3, and these will raise and lift the lid of the box and the cat so he can peek his head out. And these were modeled in SolidWorks, like I said. This and the box we have below. SolidWorks is awesome. It's used for, yeah, like I said, mechanical parts and other things like that. We have a sensor right in here. This is what can tell whether someone's in front of it, and it's an infrared sensor, motion sensor, and it will, when it senses motion, it will activate basically, or send the signal to activate the whole system. So then we have what is being lifted. I tried painting it, didn't go very well, but we have our cat here. I modeled this cat in Blender actually, because Blender's better at doing organic shapes. And you can't, SolidWorks is not very good at that. It's very hard to get non-precise organic shapes like that. So yeah, I'll show you it all put together and we can see it run. Well, actually, before that, the gear system itself, I'll show you once. When it receives input, it will just lift the cams, just like that. Perfect. All right, I have my system all put together. So let's plug him in and see what he can do. If I can find the plug. There we go. Yep. So you can see he's staring at you, just glaring a little bit. And he will remain staring at you until he stops detecting motion. Yeah. Just good little guy. Yeah. Alright, this is the overview for my code that I did for my personal project, which is the cat in a box. So let's get started. It starts out pretty simple, just with the same thing as always, setting the variables. Set our servo pin. This is the pin attached to the servo, which runs our whole system. This is an angle variable. This is a pulse. Wait, yeah, this is the right code. Jeez. This is the this is another thing we'll need for this down here, which is just how the speed of the movement essentially. And then we have just, this will be used in some calculations later. This doesn't actually get used. This is basically what Val is doing. I didn't end up using this. I guess I could comment that out. Byte sensor. We only need a 1 or a 0 for if the sensor is being used or if it's idle. So this is the first thing. It is just controlling the movement of the servo. And basically it's converting the angle it's at to the range that it uses, which I think is converting it to a voltage. I think it's like 2.4 volts to 0.5 volts. I'm actually, no, that's not right. It's just in the range. It keeps track of this internally. So this is just
basically, it pulses for the pulse width, and then it stops, which pulse is just moving it. Then we have our setup. Send some sorry, geez, my voice is dead. This is the motion sensor. We're setting this as an input. We have our indicator, and that is our output, and our servo pin is also an output. So, geez, I am like dehydrated. Sorry. Yeah, so the indicator is just like something I could plug in if I want one, but I don't, so like it would work with an LED, but I could plug it. I played around with plugging in a buzzer actually. I have it on pin 1 right now, but I played around with it on pin 13 as well. But yeah, basically that is just that will just blink when we get the motion from the motion sensor as well. I could set up a system for that, but I'm not going to for now. Then we just begin our serial, and what the heck? I think I accidentally typed some stuff in here, but yeah, we're just printing out, letting us know the thing is initialized, we're ready to go. So what we start is we set up a state variable, which sets the state of the sensor. And we're setting this equal to our value. But I don't think we actually need to do this, but I did. And then we're just writing that indicator with the state. And so if the state is 1, we know that someone is in the area, and we can run our we can move the servo to lift up the lid and have the cat look at you. This is just serial stuff for debugging, basically. And we have this loop here, which is actually the thing that's controlling the movement. So then, if the state is 0, nothing happens. And then we have a delay of half a second, and it repeats. This is just to make it run at a lower rate, and yeah, it works pretty well, and the sensor has a pretty long range, so it all works pretty great. And as you can see, it's actually plugged in currently. Down here, it's showing as I'm moving around this mouse, it's sitting right next to it. And when I'm moving my hand around, it can tell that there's motion, and it's opening up. And when I stop moving, it will close again, and then the serial monitor shows that there's nothing there. Just like that. And then once I start moving in, I'm waving my hand right now, and it's opened again. So yeah, it's a pretty simple code, but it's pretty effective. And one nice thing is it actually stays open for as long as there's people moving, and then once it stops, it closes. And I think that that's kind of more fun than just having it open and close repeatedly. Yeah. So yeah. The last thing I wanted to go over was some plans I have for this in the future. So to do that, I wanted to show my 3D model and just kind of briefly describe what sorts of flaws I found in my first prototype and ways I plan on fixing them in the future. So to get started, I have this opened up here in SolidWorks. This is the mechanics and the box. The first problem is right here, this hinge. This hinge did not print very well. Well, it 3D printed, this hinge didn't work that great. It kind of stuck up in the corners, and these are just too small to really work well. They are nice and low profile, but I think I'll need some more work on those to make those a bit stronger. So that'll definitely be something I want to address in the future. As well as originally my plan was to have the entire mechanics on this table, and my thought was that the table would fit and slide perfectly perfectly up and down. What I found in practice, though, is that any slight shifts would cause this table to bind up and basically stop anything from moving. So what I ended up doing was I just basically uh, cut off the front like this in like a shape similar to this, and so I had the cat sitting here and the paws here, and then I attached the back edge back here to the actual box, sort of like just a hinge basically. Um, and what I want to do is basically just model that in, because I found that just that tilting is so much easier to. It was firstly much less stress on the servos than trying to shift it up and down perfectly with the way my mechanics work, as well as it wouldn't bind anymore. So my plan is probably to, maybe I can even make this thinner, like make an actual mechanics for the head. Um, and this kind of leads into another change I do want to add in the future. This servo ended up being a little bit weak, so I was thinking of changing to a stepper motor or something like that, or just a larger servo. If I do end up doing that, I'm going to separate some of add another just sort of base off to the side of this mechanics and run a separate like mechanical system that will run the paws independent of the head, because currently they're all just lifting and lowering on the same plane. So that's one change I do want to integrate in the future. Yeah, the last thing yeah, those were the most major changes. The sensor and everything work great, and actually work at a much longer range than I initially even hoped for. So those are really the biggest changes, other than maybe keeping the Arduino inside of the box as well. I kept them separate because I found it was much easier to change things for this prototype. I also wanted to just show off the different ways I modeled things. This is the cat's face. I used a different kind of modeling software called Blender, and this is a lot more like sculpting clay. So if I with the tool I have now, I'm like manipulating it. So if I took like this, I can deform stuff. Obviously, I'm going to undo this or just not save it, but this is much better for organic shapes, like a cat's face, or pretty much anything you want. So yeah, just wanted to kind of show those off and show sort of a little overview of what I have planned for this in the future.